All right, let's talk about Chapter 6. If you've got an exam coming up, I know this chapter on malicious software can feel like this endless list of terms you have to memorize. But today, we're going to crack it wide open. We're going to use a powerful framework that'll help you analyze any malware scenario, not just remember a bunch of names. Let's get into it.
So be honest with me. Is your study plan right now just a giant stack of flashcards? Virus, worm, Trojan, bot, rootkit. You're just trying to cram all those definitions in your head, right? Hoping they stick just long enough for the exam. Yeah, we've all been there.
But here's the thing. That is the number one biggest mistake you can possibly make. See, your exam isn't really designed to test if you can just repeat a definition from the book. Nope. It's designed to see if you can look at a situation, a whole scenario, and figure out what's really going on. And pure memorization, it just falls apart the second the question changes one little detail. So, let's just toss that old strategy out the window. It's time to learn how the experts think about this stuff. We're going to use a super simple 4-step diagnostic framework, and this is what's going to shift you from asking, what is it, to the much more powerful question, what does it do? And that, right there, is the key to breaking down any malware problem you'll see.
Okay, step 1. And honestly, this is probably the most important one. How did the malware get onto the system in the first place? We call this propagation. And you have to get this right because if you get this step wrong, your entire analysis is going to be way off. Seriously, almost every single mistake on an exam question about malware starts right here.
So what exactly is propagation? Well, it's just the method the malware uses to get that initial foothold. Think of it like the pathway it takes to get inside. The technical term is the infection vector, but really it's just the how it got in the door part of the story. And what's so cool about this is how it connects the how to the what. A Trojan horse, for example, it has to trick a person into running it. That's social engineering. A worm, though, is different. It doesn't need to trick you at all. It actively exploits a bug in the software to wiggle its way in. Macroviruses hide out in documents, just waiting for you to open them. And watering hole attacks, they hack a website you already trust and just wait for you to show up. You see the pattern here? The name of the malware often gives you a huge clue about how it propagates. Okay, so the malware is in. Now let's move on to steps 2 and 3. These are all about understanding its basic nature, its behavior, now that it's on the system. These next 2 questions really get to the heart of what the malware actually is. First up, does it need another program to survive? Some code is parasitic, like a virus. It has to latch onto a host, like an existing program or a document, to do anything. But other types of malware, like worms or Trojans, they're completely independent. They're their own standalone programs and can run all by themselves. And next, you have to ask, does it try to spread itself? This is all about replication. Viruses and worms are really defined by this ability to self-replicate. They are actively trying to make copies and infect other computers. Trojans and bots, on the other hand, they don't do that. They just kind of sit there, waiting for a user to move them or for an attacker to tell them what to do. Now, this is a really crucial point, so listen up. Replication is not the same thing as remote control. A worm's defining characteristic is that it self-propagates. A bot's defining characteristic is that it can be remotely controlled. They are fundamentally different things, and I can almost guarantee your exam will test you on this distinction. And that brings us to the final step in our framework. The malware is on the system. We understand its nature, but what's its mission? What is it actually there to do? Well, that's what we call the payload. The payload is the malicious action. It's the part that does the damage, steals the data, causes the chaos. And for your exam, this is so important. Propagation is how it gets in, and the payload is what it does once it's inside. They are 2 completely different stages of an attack. Do not get them mixed up. And this is where a lot of the common malware names actually come from. The payload, the action it takes, is directly tied to what we call it. So if the payload is encrypting your files and demanding cache, we call it ransomware. If its goal is to join a huge network of hacked machines, it's a bot. If it's watching what you type, it's a keylogger. And trying to hide its own existence, that's the work of a rootkit. See, the payload is basically the malware's job title. Okay, so let's use this framework to tackle a classic exam topic. If we have all these security tools, why do they fail sometimes? Well, the answer isn't that the technology is bad. It's about the built-in limitations, the design trade-offs that clever malware is specifically designed to exploit. Just think about these trade-offs. A sandbox can't watch a program forever, right? So smart malware just waits. It delays its malicious activity. A behavior blocker has to let a program start running to see what it does. But by then, maybe a little damage is already done. A worm that slips past the firewall can then run wild on the internal network. And your classic antivirus, it's always playing catch-up because it can only spot malware it already knows about.
So, after all that, how do we boil this down into one single, powerful tool you can actually use when you're sitting in that exam room staring at a tricky question? It all comes down to one simple question you need to ask yourself every single time.
Burn this sentence into your brain. How did it get in? What trust did it abuse? And what did it do next? This one question perfectly maps to our entire framework. How did it get in? That's your propagation. What trust did it abuse? That's the mechanism. Was it a software bug or a person's gullibility? And what did it do next? That, my friends, is the payload.
By asking this one question, you stop being someone who's just trying to remember a list of definitions, and you start deconstructing the problem. You start thinking like a security analyst, and that is exactly how you're going to get the right answer on your exam. You got this.